Hello friends. In continuation to my previous session yesterday, today we shall discuss more topics related to theory, and we'll try to clarify those topics which generally we don't discuss and concentrate during theory sessions. Before we go further for theories, yesterday we were talking about errors which generally we get through compiler, and we don't concentrate on it. Few errors are pending to be mentioned. So first let me quickly summarize those errors and then we shall go on some theory topics. In errors, sometimes we find misplaced continue or misplaced else. Misplaced continue comes when we write continue keyword somewhere outside the loop, and misplaced else is generally found as error when you write else either without if or some curly braces misplaces. These are some of the symptoms when we get continue and else types of errors. Misplaced very clearly mentions that you have done something wrong in terms of writing either continue or else in your program. While dealing with pointers, frequently we fear about lots of errors we are getting for pointers. Non-portable pointer conversion is frequently observed errors among them. Non-portable conversion is a kind of error which comes when we are trying to convert address from a pointer type to some routine data type, like trying to store address into float or maybe character. Though pointers are containing addresses and all addresses are of type unsigned integer. So such conversion which are not allowed are indicated by mentioning this error, and always when you get this error you go to that line and observe that instead of storing or retrieving addresses from pointers, you might have used some other types. That is root cause for this error. Too many decimal points is an error generally we see during initialization. I have an example to see. Here in a float I have given float, then the variable name is z, and the value assigned to it is 24.5.3, and as we all know, real numbers don't see like this. So when you write this way, the compiler is going to identify it as error, and this error is mentioned as too many decimal points. The second similar error we get is too many initializers, and I have example for this. Here a character is declared with a variable name AA, and this character contains 5 elements, but the value assigned to it is something more than that. In my value what I have added is this is first, and if you count number of characters, they are more than available elements in array. During initialization you are not allowed to assign more number of values than the availability in your array. So AA contains 5 character elements, and during initialization you cannot have more than 5 characters as initialization, and that's why this line is going to give you error, and the name of error would be too many initializers. The next error is too many types in declaration. While declaring variable, we used to write single data type only. So either we write integer or float or character, and sometimes we also write structure and union type as a type for the declared variable. Sometimes we also use a signed and unsigned keyword, static and constant keyword, but we never mention two data types on the same line to declare a variable. For example, writing character space integer space a. When you by mistake when you type this, the compiler gives error too many types in declaration. So that is one more error. And the next is unable to open include file and then the name. Every program may contain include as a first syntax sometimes to mention. Now this first syntax indicates that I want to include a file. No doubt this syntax is errorful, but we generally like hash include angular bracket then file name dot h and angular bracket is closed. If this file is not found, or in case you have mentioned your file name in double quotation and that file is not found, then such error is prompted by compiler. So error says unable to open include file. You might be knowing if you are mentioning file name in angular braces, then that file is searched into the directory mentioned in the option of your editor or maybe through the command line to initiate compilation. And if you mention your file name in double quotation, that file is searched in the directory where your source program is. So that is difference. But in case out of both of these locations file is not found, the error is prompted on screen. One more error is unexpected end of file in comment started on some line number. Exactly when this happens? In my program, see the end of program, and end of program is I have my routine program, then I have started comments. By mistake, comment is not ended, and so the end of program is also commented. So when main contains such problems, unexpected end of file in comment started on line number, error comes. It indicates that you have started comment on so and so line number, but it was not completed, and it is possible that that is also containing completion of program called closing curly bracket of main. So if this error comes, directly jump to the end of your main and check whether main is closed perfectly or not. Friend, these were some of the errors you should know. You should be very clear about exactly how error comes and how to solve to make your execution faster. We are confused when lots of errors are popped up and we are messed up with the program. So I have mentioned few of the errors to improve your programmability. If you know error, you exactly know how error is generated, and you also know the solution, and which will make your programming faster. Now jumping on to some theory concepts, I have collected few points which are related to theory explanation, and generally we get confused into it. The first point I want to mention is mixed mode arithmetic. This creates problem during programming, but understanding in theory is highly required to eliminate all your programming problems. I have example for this. In my example, I have integer a, b, ans1 and ans2, as well as I have float d, e, ans3 and ans4. And now the next step is ans1 is equal to a by b. So my intention is to divide 5 by 6, and whatever answer comes, I want to store it into answer 1. This type of arithmetic is known as integer arithmetic because we are talking about operand a and b as well as operator slash or divided by. Always what type of arithmetic you are going to perform depends on operator as well as given operands. In our example, a is divided by b, where operator is divided by, and operands are a and b. When we divide 5 with 6, we are expecting some real number as outcome, 0 point something or maybe. But when exactly the answer comes up on screen, answer is totally different. And there is a clear logic behind this. Actually, arithmetic is responsible for this, and rule is for any arithmetic operator, the type of operands are deciding what type of result you are going to get. If both the operands are of same type, then result would be in that type itself, and this is case in our said example. Operator divided by contains two operands and type of both the operands are integer. Regardless of you are storing your answer into float or integer, your answer would be integer. If you are storing it into integer variable, your answer is integer, and if you are storing your answer into float variable, then your answer would be in real number, but you would not have any decimal places. Instead you will find .0, and that is because of this is known as integer arithmetic. If two integer variables are operated arithmetically, the result is always in integer. So first example, a by b is going to result in integer, but the second example is something different than first. A is divided by d. Here arithmetic operator contains two operands a and d, where a is of type integer and d is of type float. This type of arithmetic is known as mixed mode arithmetic, and here actual value 5 is divided by 6.7. Remember, when two different types are associated into arithmetic, resulting answer always comprises of data type which is bigger. So in integer and in terms of float, the bigger data type is float, and your answer is going to result as float. Now it depends whether you are storing your answer in float or integer, you are going to get your final answer. In the given example, we are dividing a with d. Though arithmetic is mixed mode, your answer would be resulting in real number, but because of your answer is stored in answer 2, where answer 2's type is integer, and automatically your real answer is typecasted into integer, and whatever integral part you have in real number is stored into answer 2. So in first and second case, we are expecting some real number as answer, but if we execute this program, we don't get any real number as answer. Instead, we are going to get 0 in both the cases. Third case is answer 3 is equal to d by e, where d is a real number, e is also a real number, and they are declared as float. So this arithmetic is performed on two operands, where both the operands are having type real or float. So this is again called real arithmetic because both the operands are of type real, and answer would be in real itself. When two operands are of same type, answer is in that type itself. But the fourth example is d by a, where d is of type float and a is of type integer. And again this example is best example for mixed mode arithmetic, where two distinct types are associated with the given operator and mixed mode arithmetic is performed. In case of d by e, your answer is resulting in real number. Now whether you are going to get real number or integer as outcome, that depends on in which case, in which type of variable you are storing your data. D by e is stored in answer 3, and answer 3 is declared as float. So your real answer is stored in a floating point number called ans3. In case of fourth example, d by a, though it is mixed mode arithmetic, and whenever arithmetic is mixed mode, resulting answer is in a bigger type. In case of float and integer, bigger is float, and you are going to get your answer in float, and this float number is stored in float variable itself. So it remains variable, it remains float and stored in variable, and outcome is a real number. Let us execute this program to check exactly what comes up on screen, and minutely observe, the first answer is 0 and second answer is also 0, because arithmetic was either integer or mixed mode, but ultimately found answer was stored in integer variable and it was implicitly typecasted. In first case it was integer arithmetic and was stored in integer, so it is 0. In second case arithmetic is mixed mode, but it was implicitly casted and stored into integer because resulting variable is integer. But in case of third and fourth, answers are real numbers, because in case of third example arithmetic was real and it was stored into float variable, so it remains real number. And in fourth case, though it was mixed mode arithmetic, real number and integer, and answer was in real number, it was stored even in real number, and so it remains real number. So in first and second cases we get integer because of resulting answer is stored in integer variable, and floating point decimal points are discarded. In third and fourth cases decimal points are kept. So during your coding you should remember that arithmetic is performed on the basis of types associated to the operator, and it is very important to concentrate on this, because sometimes it generates meaningless results and we get confused exactly why this is happening. This is happening because it is either integer arithmetic, real arithmetic or mixed mode arithmetic. The next very frequently asked question is, should we use goto? Well, as far as programming paradigms are concerned, goto was invented. Goto is definitely part of most of programming languages, but you should not use this. Initially, we were following a procedural sequential execution pattern, where execution of program generally starts from line 1 and goes up to line last. Then slowly they introduced branching, we call it decision making, and we used to divert our execution from top to bottom, but somewhere in between it was diverted to either of the ways, because we have if else. Then they started using loops, where